Good morning. I had some questions about yesterday's math, and I'm going to try to go over those without, this is going to go in our main lesson book, so I don't want to destroy it. So we're going to use this space right here to talk about what I want to talk about with you. The first one was, do I have a curricula for this? No, I am doing this on my own. We're in 7th grade now. I do not have curricula written this far. I do have math guides that are on my website, thebeautyofplay.com, that you can go and look for. They cover different concepts. If you have any questions, let me know. For this exponent work, I am not using that. The largest source, I would say, is from my study of Gattegno's work. He uses crosses, towers, and L's, which I'm going to go over again in just a second. Having said that about curricula, that I don't have any written and I'm not using any at this moment, I do want to say that I feel like these rods can be used with any curricula. They just physically manifest the math. So you can do these concepts. If you are in my subscription, there's an overview of how the rods work. It is like the first content drop, so it's at the very bottom of your membership. If you don't see what you need and you're in my membership, contact me. I will make sure that you get what you need for your math program anytime. If you're part of my subscription, just ask away and I will explain it to you. Okay, the next question that I had about this is, are the kids confused? Because this just looks like a stack of rods. It's not the same number as the number that we would get if we calculated 2 to the 5th. Like, are the children confused by this? And no, they're not. And I'm going to show you why, because these are, as you go along, these are really tiny jumps. Okay, I showed you yesterday when we were talking, when we are first introducing concepts, we are making trains, which are end to end here. And then if you are making mats, and this is from Gattegno's work. He's not the only math educator that did this. There are several, but you will also see similar things in Math You See, because that is based on Mortison's work, which is based on Gattegno's work, and yeah, so you'll see it there. Okay, so this would be a mat if we are putting rods underneath. Now when you get trains like this becomes our model for multiplication, right? You count the number of rods you have. So on these purple, I have 3 of 4. In Gattegno, who thinks that we should do algebra first, it would be 3R, or 3 of R, right? On these red ones, I have 1, 2, 3, 4, 5, 6. So it would be 6 of 2, or 6 R's, right? Or 6 times R. Because we're counting what we have in common. We're counting. This is really important in upper level math and algebra. Okay, so we have that. Eventually we move into, and I'm just going to use these, area model multiplication. And the reason that we do that, see, this is 3 and this is 4, is because when we look at more complex math multiplication problems, we need to be able to break things up into place value. Here, I want to try to use the rods for this. Okay, this is area model multiplication. You can see I've used as many 10s as possible, and this also is like slow work. One of the challenges you're thinking that this would be confusing for kids is because I've jumped really fast from one to the other so that your brain can make the connections. With children, this is slow going, this is slow work, right? So on one side of this, I have 10 and 2, right? There's my 10 and 2. And then on this side, I have 10 and 4. So my problem is 12 times 14. And when I separate by place value, it's very clear in multiplication that everything is multiplied by everything, right? This would be our 10 times 10. This would be our 4 times 10. I have 14 there, but this is just supposed to say 4. And this will be our 10 times 2, and this will be our 2 times 4. It's everything multiplied by everything. When you're doing the standard American algorithm, you're doing this, I promise. In multiplication, you have to multiply all place values by all other place values in the other number. This area model multiplication leads us into a representation of the rods of crosses. And this is done by first making the connection that, I think it's the cumulative property, right? That it doesn't matter what order it is. So I can have 4 3s and it is exactly the same as 3 4s. When I have this, when we've done this work for a while, it's really easy to see the crosses like this. And the crosses come in a lot with factor work, right? So if we're looking at the number 24, and I'm going to look at this because 24 has a lot of factors. What are the factors that I can have for 24? I can have 24 times 1, right? This would be 1 tower. I can make another array that is 6 times 4. Here, this is just a shortcut, remember. I've either got 4 6s or 6 4s, but 6 times 4. And then I can also have one 3 times 8. I've done 24, but I've forgotten my other 10 there. And then I can also have 12 times 2. You get my drift here. There's lots of work done with the crosses. So this idea of multiplication is not a hard jump because there's lots of work here, and it is directly coming from that last step of area multiplication. Okay, let's talk about prime factorization. And this is my favorite way to do prime factorization because I don't know about you, but for some reason factors get dropped, right? As soon as you have it, they don't write the 2 anymore. In our towers, factors are not dropped. So we're moving from our crosses to the towers. The first thing that we're going to do is, can we find 2 factors for 24? And I'm going to use 6 times 4, mostly because it's just so easy and stable. Okay, are both of those prime? No, they are not. Okay, let's substitute our 4. What will we substitute our 4 for? We would substitute that for 2 times 2. You see that? Now we have combined 2 crosses, our 2 times 2, which is what 4 is, multiplied, and our 6. And now we also know that our 6 is not prime, so we are going to substitute our 6 with 2 times 6, and now we have 3 times 2 times 2 times 2. And this is our answer. And we actually introduce exponents. I don't know why people get so hung up on exponents. I see all kinds of curricula like, do not mention exponents till 7th grade. whatever. Like, why do extra work, folks? There is a shorthand for this, and that's all that needs to be explained, right? So I have 3 times, how many 2's do I have? How many 2's am I multiplying? 1, 2, 3. I am multiplying 2's 3 times. So I'm just going to write that notation down. So because we're doing prime factorization, because we're doing so many factor works, because we are combining our crosses, right? Because this was our 4 and this was our 6. There's not a lot of confusion when you get to this point, because this is the prime factorization. And then when you move to the towers, it's just another shorthand, right? Like, oh, my tower is getting really tall. It's all the same one. It's going to fall over soon. What is another way that I can represent these rods that are more stable? Well, here's my base. This is what I'm multiplying over and over again. And this one, let's just take this off, make this easy on me. It's 4 high, so I'm multiplying 1, 2, 3, 4 high. And so now my L's are, this is my base, and my tower is 4 high. So this is 2 to the 4th power. It also lets you see that that our bases are very distinct, right? Like we can't add these two here if we've got 3 to the 6th power times 2 to the 4th power. Let me just write those. We can't just add these, so because they don't have the same bases. So it makes it obvious what we can and can't do with exponents. We can't just take this one and add it here, but we can do that for our 2's. So if I have a 2 to the 4th and a 2 to the 5th, I can take this and just put this up here for my L and have 2 to the 10th. And these, I feel like, just make understanding math so much easier, especially for some children that are more tactile and need to see things. This makes it so much easier.